Hello, today I want to introduce you to graphing exponential functions. So we're going to look at several examples. We're going to graph them by hand, and we're also going to compare them on Desmos so we can see if there's any patterns going on as we graph them. This is the first thing I want you to do. This says use Desmos to complete. I actually kind of prefer that you use Desmos to check your work. So I'm going to take you through the first example, and we're just going to make a chart, an XY chart for 2 to the x. So we have y equals 2 to the x. And I'm going to start actually at 0 right here, and then we'll look at the negative exponents in a moment. So 2 to the 0, remember anything to the 0 is just 1. And then we're going to have 2 to the first. When x equals 1, y equals 2. 2 to the second power equals 2, written down twice and multiplied, which is 4. So 2 squared is 4. And then we've got 2 cubed, and that's going to be 2 written down 3 times and multiplied out, and we get 8. Remember that when we write something to the power, it's the simplification of multiplication. I know it's all rhymey there. Simplification, multiplication. So instead of writing out 2 times 2 times 2, I can just write 2 to the third power, and that makes things a little bit easier when we're writing this stuff out. Anyway, these are my y values for when x equals the exponents right here. So these are my x values, and then my y values come out like this in the chart. So I can write 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. And 2 cubed is 8. We can also graph those points. I'm going to use a pen. I usually like using marker because they show up better on the video. But I think using marker right here is going to make everything smudge together. So when you put in 0, you get 1. When you put 1 into the function, you get 2. 2 squared is 4. And 2 cubed is 8. So you get this nice curve coming through like this. But we want to know what else happens on the negative values here. Or is the function even defined there? So that's what we're going to look at next. So when I've got 2 to the negative 1, remember what that does. This is like saying if we write it like a fraction, that negative exponent drops the base and the exponent into the denominator and flips the sign. So it's the same thing as saying 1 over 2 to the first power. And we know 2 to the first power is the same thing as 2. So we get 1/2 there. So 1/2 goes right there. When I say 2 to the negative 2, that's the same thing as 1 over 2 squared. It drops this whole thing right here, goes to the denominator, and that exponent becomes positive. So that's the same thing as 1 over 4. And then 2 to the negative 3 is the same thing as 1 over 2 cubed, which is 1/8. And so we can quickly see that as we go to the left here, everything is getting smaller and smaller and smaller. Notice that 1/8 is smaller than 1/4, and 1/4 is smaller than 1/2. And so things are getting closer and closer and closer to 0. But do we ever reach 0? Well, as we've discussed already in this class, there's nothing I can put in the denominator of a fraction that's going to make it equal 0. So as this number right here on the bottom gets bigger and bigger and bigger, and it will as we go to the left on the x-axis, it's never going to reach 0, but it's going to get super close to it. So we actually have a horizontal asymptote going on at y equals 0. And so that's what our graph looks like. Let's take a look in Desmos and see what the actual graph looks like when it's graphed 100% correct. So we're going to click on Graphing Calculator, and I'm going to say y equals 2 to the x. And that's what our graph looks like. And you say, well, it looks like it hits 0 right here, but notice if we zoom in, the more we zoom in, the more we can see what's going on. It's getting closer and closer and closer as we go out to the left, but never quite there. So that is y equals 2 to the x graphed out. Now, on our actual paper here, we've got a couple of things we need to do. We need to do it for a base. Remember, we call this right here our base of 3 raised to the power of x. and then we need to do it for a base of 5 raised to the x. We're going to do the same values here. You can use a calculator. Like if you don't know what 5 cubed is, use a calculator if you want to, and then write in your answers. Remember, I don't want decimals here, so just give me the fractions. Then for number 4, we're going to do 10 to the x, and number 5, we're going to do e to the x, which we will explain what e is here in a moment. So graph all these. You can use, actually, when you're doing this, you can use the E button on your calculator when you're finding the actual values. I guess in that one, it's okay to use a decimal. All right. And we're going to graph all 5 at once. We're going to do that in Desmos, but we'll save that for a moment. Go ahead and finish the rest of these charts and try graphing them out. All right. Pause the video and do that. All right. I've taken it, you've given it a try, and let's take a look and see what you got for your graphs here, or what you should have gotten. And I've got 3 to the x looking like this, and here are my values. If you can't see those, let me zoom in a little bit. That is 1 over 27, 1/9, 1/3, 1, 3, 9, and 27. What makes it nice is if you start right here and go 0 through 3, these are just the reciprocals of that, right? So it makes it nice and easy to do the others. Same thing with 5 to the x. 1, 5, 25, and 125 are 0 through 3. And then taking the reciprocals up here, you get that. And so your shape looks similar to the first two, right? In fact, if I just flash these really quickly across the screen, it's hard to tell the difference between them. But we're going to see in Desmos, hopefully, the pattern that makes these different. Number 4, these are the values I got. This is to the 10th. Now, this one might start to look a little bit different. Hopefully, you're noticing that goes up pretty steeply. And if you were graphing that by hand, you notice, like, I can graph x equals 1, but x equals 2 is up at what, 100, and x equals 3, man, that's at 1,000. There's no way I can graph that on here without scaling it. Now, as far as this one goes, you may not have been introduced to E yet. And I've got a great video I found on YouTube that introduces you to E. I'll probably share that with my classes, or I will link it eventually in the description on this video, so that people that are not in my class can see this video that this guy did. It's great. Explains E and where it comes from. For right now, though, in this, what I want you to know is E is about 2.71828. We usually just use 2.71. It is a number, kind of like when we talk about pi and we say pi is 3.14. We know that pi is a number, and the approximation of that is 3.14. It's an irrational number, non-terminating, so we never do get the full value unless we punch it in the calculator as pi. Same thing with E. It is a special number with some pretty cool properties. Once again, it's going to be in that video. It's for another discussion. But what I want you to see and notice is that E is between 2 and 3, and it's actually closer to the value of 3, right? It's 2.7 something. And it can be used as a base to a exponential function just like any other number, and this is what the graph looks like. It's really close to 3. So if I were doing 3 to the x, let me pull that graph right here and look at these two. 3 to the x goes through 0, 1, and here's 3 to the x. I'm sorry, that's 5 to the x. 3 to the x goes through 0, 1, and 1, 3. Notice that e to the x goes really close to 1, 3. It's at 2.7. In fact, you can't even tell the difference on mine because it's so close in here. We will look at it in Desmos, though, and see what, how close it is to 3 to the x. Let's do that now. Let's switch over to Desmos. Here's where we had 2 to the x graphed, and I'm going to go ahead and put in the other problems here. The second one said to graph 3 to the x, so let's do that. Y equals 3 raised to the power of x, and right there it is in blue. And then we've got 5 to the x for number 3. There it is in green. And then what else did we have? We had 10 to the x. Y equals 10 to the x. There it is in that dark purple. And then finally we had e to the x. So you can just type in e, and notice that Desmos already picks up on it and says, hey, that's 2.7182. That's how special it is. Desmos has it saved. And that's e to the x right there in black. So this is what we get. It's kind of pretty, isn't it? And we notice something here that they're all tied where? It's like, I always think of it as a bunch of strings, and it's like somebody pinched and tied them up right there at 0, 1. And that should make sense because as we're looking at these charts right here, they all go through that point 0, 1, don't they? And that makes sense. Anytime you raise it to the 0, you're going to get 1 as your output. So that's one thing that I want you to note when you're graphing exponential functions. If there's no transformation going on, you raise something to the 0, you're going to get 1. I'm looking that you graphed it through that point there. And if there's a transformation where it's being shifted around, that point should shift according to the transformation being done to it. So that's our first thing. The other thing is, without any transformations, is that they are headed towards the x-axis as you go towards negative infinity. Or in other words, we have a horizontal asymptote at y equals 0. And then if we zoom out, we can see what else is going on with the graph. Let's compare just 2 to the x and 10 to the x. So 2 to the x is written in red, 10 to the x is written in purple, and we kind of notice, just like when we graphed it by hand, that as this base right here gets larger, the steepness of this graph increases, doesn't it? It bends towards the y-axis very quickly. In fact, let's try putting in a slider and seeing what that looks like. If I say y equals a raised to the power of x, notice it says, do you want to add a slider? I sure do. And I'm going to make this so it's just positive values. So let's do, let's not do 1, let's do 2 to 100 here. And I don't want any fractions. Let's just do step by 1. And let's see, can we graph this? So it's in red. Let's turn off 2 to the x so we're not confused there. And we'll turn off this one. And drawn in red right here. Notice as I drag 2 to the right, so my a value over here, if you look at it, this a is my variable, and this is what I'm changing. This is now 8 to the x. And as I drag it to the right, it's now 10 to the x, 17 to the x, or 18 to the x. And so as I drag it to the right, look at the graph. It's getting closer and closer to the y-axis. As I drag it and make that number smaller, it bends away from the y-axis. In fact, if you don't want to try to drag and watch at the same time, you can hit play, and it plays for you there. So as it gets larger, it moves towards the y-axis. Now it's getting smaller, so it's moving away from the y-axis. And so that's something to note as you go through these. All right, let's do one more thing. Let's compare e to the x. Like I said we would. That's e to the x. Here's 3 to the x. Notice they are very close to one another. Which one, without looking, which one is closer to the y-axis? Well, it's 3 to the x, isn't it? And we know that because e is at about 2.7 and 3 is larger. So as we just discovered looking at the slider down here, as that base is larger, it bends closer to the y-axis. This is without any transformations going on. So since 3 is larger than 2.71 something, the blue graph is going to curve towards the y-axis a little bit sooner than the black graph there. Okay, let's take a look and see if there are any other questions we need to answer. So it said to graph all 5 at once. What do you notice? We talked about it being tied in there at 0, 1. And we talked about the generalizations, about what they have in common. They all shoot up really quickly, but as the base gets larger, it bends towards the y-axis. We also have a horizontal asymptote on all of them at y equals 0. And it says to write as many as you can. So now I've listed the most common ones I've noticed whenever I teach this class live and in person. Maybe you noticed something about exponential functions I didn't mention in the video. If you did, please comment or send me a message or ask me in class, bring it up so we can share it together as a group and learn from one another. All right? Thank you for watching, and let me know if you have any questions.